Frank and 25 other students are candidates for a prestigious undergrad program. All these candidates were required to take an entrance exam. The scores are below. Frank's score was 75%. So looking at our stem plot, we can see that he is right here. So right here, there are 8 people out of 26 that scored below him. That is 30.8% of other candidates scored below Frank's score. This places him in the 31st percentile. That is because 31% of candidates scored below him. Another way of saying it is he did better than 31%. This also means that 69% scored above him. So a percentile is the percentage of values that are below a given value. We want to find the percentile rank of the person who scored 80%. So in our stem plot, here's our person that scored 80%, and there are 13 people that scored below. 13 out of 26 places this person 50% higher than the other candidates. So this person is in the 50th percentile. They scored higher than 50% of people. Next, we want to find the percentile rank of someone who scored an 89%. There are 3 people that scored 89%. It doesn't matter which 89% you're looking at, you're still counting the number of people that are below 89%. So we're looking from 84% and below. So there are 20 people out of 26 who scored less than 89%. That means that there are 77%, which puts this person at the 77th percentile. Next, we're trying to find the percentile rank of someone who scored 58%. As you can see, 58% is the smallest score on this graph. That means that there are 0 out of 26, or 0%. Well, here's the thing. There's no such thing as the 0 percentile. If this were to happen, it is the only time where you wouldn't round normally. So this person is in the 1st percentile. This means that 99% of candidates scored higher. And if we look at our last one, we want to find the percentile rank of the person who scored 93%. 93% is the highest score on this test. So 25 people out of 26 scored below. This places this person in the 96th percentile. Since you're always looking for the percent that scores less, you will never have the 100th percentile. Maximum you'll have is the 99th percentile. So take a moment and pause the video. Try the following problems. Stop when you get to letter D. So the answers to the practice problems are as follows. There are 5 teams out of 30 that's had less losses than the Colorado Rockies. That puts them at the 17th percentile. The New York Yankees, who lost 59 games, there were no teams that had less losing games than them out of 30. That puts them in the 1st percentile. Philadelphia Phillies lost 69 games. There were only 4 teams out of all 30 that had less than 69 games lost, which is 13.3%, and if we round that to the nearest whole number, that puts them at the 13th percentile. In 2009, the manager of the Washington Nationals was under public scrutiny because the Nationals didn't make the playoffs again. In a press conference, the manager said, "Even though we didn't make the playoffs, we should be really proud of our guys. We were in the 97th percentile of losses. Should Nationals fans be proud?" Explain. 97th percentile means that (97% of teams had less losses. Or in other words, 97% of teams, or the Nats had more losses than 97% of teams. That is pretty bad. 97% of teams had more wins than they did. Therefore, I don't think you should be proud as a Nats fan. But they can be this year because they're NL champs. So we're going to take this data and we're going to make a different type of graph called a cumulative relative frequency graph. And to do that, we need to make a table. So we're going to go back to the original example with Frank. So with Frank's example, there were 6, we're going to make 5 intervals. So test scores for Frank were 58 to 65, the way I figured this out is because there were approximately 26 data points, which is going to be approximately 5. So that's how I got 5 bins. Then I took the highest score and the lowest score, subtracted them, and divided by 5, which gave me intervals that were approximately 7. So what we want to do is we want to find our cumulative relative frequency. So we already know how to find frequency, pretty easy. When we go back to the table at Frank's scores, there are 2 people who took the entrance exams who got between 58 and 65. 5 people got between these scores, 6, 7, and then 6. We know that relative frequency is the percentage, so there was 2 out of 26, so 7.69%. 5 out of 26. So these aren't new. The new part is called cumulative frequency. So cumulative means total. So after the first interval, we still only had 2 people total. After the second interval, there are 7 people that fall within those 2 categories. Cumulative means total. So next we had 6 more people in this interval, which brings our total to 13. The next interval had 7 people in it. That takes our total number to 20. And finally, 6 more people takes our cumulative frequency to 26. Our final number should be the total amount of individuals in the data set. So cumulative relative frequency is just like relative frequency, however, we're using the values from the cumulative frequency. So stays the same, 2 out of 26. But now we're looking at 7 out of 26. Then we have 13 out of 26. Oops. Sorry, that's 26.92. 13 out of 26 is 50%. Then we have 20 out of 26, which is 76.92%. And finally, 26 out of 26, which is 100%. We're going to use this data to make a new graph called a cumulative relative frequency graph, or an ogive. So here's our axes. We're going to set them up on our x-axis, just like we did the intervals. So we're going to have an interval from 58 to 93. And these are the test scores. On the y-axis, we're going to have our relative frequency, cumulative relative frequency. And since we need to make 100%, because we know after the cumulative is going to end up at 100%, I'm going to count by tens. So starting at our first value, we have 0. But between 0 and 65, there was a cumulative relative frequency of 7.69. So between this interval, we had an increase of 7.69%. So that's approximately here. Then from 65 to 72, the cumulative relative frequency was 26.92. Then the next interval, we had up to 50%. Then we went up to 76.92%. And finally, 93 reaches 100%. So our graph looks like this. What's nice about a cumulative relative frequency graph is that you can easily tell percentiles. So we want to estimate and interpret the 45th percentile. So 45th percentile is where 45% of the data falls below. So here's 45%. We follow it over. So we'd say that that is approximately 78 games. %. Sorry, not games. It must be 78%. 45% of candidates, the test takers, scored below 78%. We can use this to estimate the median. So we know that the median is the 50th percentile. Go over to a graph. 50th percentile we know is going to be 79. This means that approximately 50% of candidates scored below 79%. Next, we're going to estimate our lower quartile. So lower quartile we know is Q1. Keyword is quartile, which is 25%. So we're looking for the 25th percentile. We go over to the graph. We find 25%, which is here. Follow it down, and it looks like, if we want to estimate, it is approximately, let's say 71%. That means that 25% of candidates scored less than 71%. And our upper quartile is going to be the 75th percentile, again, quartile being quarters. So we follow it to 75%, follow it down. Slightly below 86, so we'll say approximately 85%. So you would need to get an 85% in order to have 75% of the people scoring less than you. So I'd like you to pause the video here and see if you can create a cumulative relative frequency graph for the data using the Major League Baseball teams. So your graph should look something like this. Is we need to make a table. Our x-axis is going to have the same labels as our intervals. So 59, there's nothing. 6.67. 26.67. 56. 76. 93. 100. Estimate and interpret the 10th percentile. So the 10th percentile is here. So we'll say approximately 68 or 69. We're going to estimate the median score. We know that's going to be the 50th percentile, so that's right here. So that's approximately 79. Oh, forgot to interpret. So 10% of teams had less than 68 losses. Our lower percentile or lower quartile is 25th percentile, which is approximately here. So we'll say approximately 74 losses. Here's our 75th percentile. Upper quartile, here's 75 approximately. Say approximately 85 losses. So, wonder what the cumulative relative frequency graph would look like if we had symmetric versus skewed data. So if you can imagine, if you have symmetric data, it would look something like this. So let's say that if we found the relative frequency, this could be 10%, this could be 20%, 10%, 20%. So that gives us 40, 60, so we'll make this 40%. So imagine if you were going to make a cumulative relative frequency graph instead, you would go up 10%, then you go up 20%, so a total of 30, and you would go up 40%, so it's getting steeper, and then it would level off. You're going to add another 20, and then another 10. So a symmetric cumulative relative frequency graph would also be symmetric. If you folded it, you would get something that was symmetric as well. If the graph was skewed left, so we know that skewed left means our tail is on the left. So 50, 60, 40. And you converted that to a cumulative relative frequency graph. You would start again slow at 10%, then you're adding to 30%, then you're adding another 30%, so it's getting steeper, and then it's getting even steeper. So you would see a slow increase and then a rapid increase because most of the data would be towards the right side or the larger numbers. Which means that if you're looking at something that is going to be skewed right, imagine that our tail is on the right. We're going the opposite direction. This would be 40%, 30%, 20%, 10%. Our cumulative relative frequency graph would start rapidly. It's going up to 40, then less rapid, then less rapid, then less rapid. So this one increases quickly, and then the percentages level off because there's not as much data in that end.